Good morning, Matrix. Welcome to the last online lesson for this term before you have a well-deserved rest. Well done to everyone for hanging in there in this very strange times that we are living in. But I think you guys have been great. So the last little bit of work that we're doing for the term is double angle trig formula. Okay, and we're going to start off with the proofs. They're really pretty easy. And the first proof says that sine of 2 times an angle, okay, is 2 sine of half that angle cos of half that angle. Otherwise, you can just say sine of an angle is 2 sine of half that angle cos of that angle. Okay, that's how you need to think about it. Okay, so to do the proof, okay, try give it a go. You're just going to be using that logic. The compound angle sine formula, that sine A plus B is sine A cos B plus cos A sine B. Okay, so you're going to start with the left-hand side, which is sine 2A. And I want to use the compound angle formula. So how can I write the angle 2A as a sum of 2 angles? Well, it's just sine of A plus A. Right, so now go apply this formula. Sine of an angle plus another angle. What's that equal to? Okay, give it a go. And it's going to be, well, sine of an angle plus another angle is sine of the first angle, cos of the second angle, which is also A, sine with the same side, okay, plus cos of the first angle, sine of the second angle, which are both A. Sine A, cos A, sine A. For the same thing, 2 times 3 is the same thing as 3 times 2. So an apple plus an apple is 2 apples. So sine A cos A plus another sine A cos A is 2 sine A cos A. And that, guys, is your first double angle formula. That sine of 2 times an angle is 2 sine of the angle cos of the angle. Okay. Right. So using similar logic to what we did number 1, I want you to try prove 2A. Prove that cos 2A is equal to cos squared A minus sine squared A. Now we're going to be using the cos compound angle formula, which is that cos A plus B is cos A cos B minus sine A sine B. Right, give that a go. So, cos 2A is the same thing as cos of A plus A. Okay, and cos of A plus A using this formula is cos of the first angle, cos of the second angle. Cos, what's messed up about it is the sign in the middle, so it's going to be the opposite sign, so it's going to be minus sine of the first angle, sine of the second angle, okay, which is equal to cos A times cos A is cos squared A minus sine squared A. So cos of 2 times an angle is cos squared half that angle minus sine squared half that angle. Okay. Just to mention here quickly, so what this formula is saying, the fact that sine 2A is equal to 2 sine A cos A, just a numerical example quickly. Well, it's saying that sine of 60 degrees, okay, is 2 sine, or what's the relationship between A and 2A? A is half of that angle. So sine of 60 would be 2 sine 30 cos 30. We could write it like that. Okay. And likewise over here, we know that cos 2A is equal to cos squared A minus sine squared A. So numerically, let's say I had cos 80 degrees. Cos 80 degrees could be written as, well, cos of an angle is cos squared half of that angle, so it'll be cos squared 40 degrees minus sine squared 40 degrees. So that is what these formulas are saying in numerical terms. Right, cos 2A, though, can be expressed in 3 different ways. We've shown that it's equal to cos squared A minus sine squared A. Okay, the next question says hence. In other words, using the fact that you know that cos 2A is cos squared A minus sine squared A, hence, go show that cos 2A is 2 cos squared A minus 1. Okay, give that a go. Well, we're going to start off with using the fact that we know we've proved that cos 2a is equal to cos squared a minus sine squared a. But now we want to show that it's equal to 2 cos squared a minus 1. So we're using this to prove that. Okay? So I've got to get sine squared in terms of cos. Now you should know that cos squared a plus sine squared a is equal to 1. So what's cos squared a going to be if we manipulate that equation? Cos squared a is going to be equal to 1 minus sine squared a. And likewise, sine squared a, if I move that across, is going to be equal to 1 minus cos squared a. Okay, so those, we're going to use that to help us. So now I think it should be pretty obvious. We only want cos squared, we don't want sine squared. How do I turn a sine squared into a cos squared? Well, sine squared is equal to 1 minus cos squared a. So cos 2a is going to be cos squared a minus sine squared a is 1 minus cos squared a. Distribute the negative, and I get cos squared a plus cos squared a, which is 2 cos squared a. And then I've got negative 1. So cos 2a is also equal to 2 cos squared a minus 1. What does that mean numerically? Well, if I had cos of, let's say, I don't know, 40 degrees, we could write it as 2 cos squared. Cos of 2a is cos 2 cos squared a minus 1. So cos of 2 times an angle would be 2 cos squared. Half of that angle minus 1. That's what that law is saying over there. So for cos 2a, so far we've got two proofs. We've shown that cos 2a is the same thing as cos squared a minus sine squared a, and hence cos 2a is also equal to 2 cos squared a minus 1. Right, your final proof, again hence, in other words, using this answer, prove that cos 2a is equal to 1 minus 2 sine squared a. Okay, so now, at the moment, for this proof, which is that proof over there, we want to start off again with the fact that we know that cos 2a is equal to cos squared a minus sine squared a. Right, but now I want to show it's equal to that. So I don't want a cos squared a in it. I want to express cos squared a in terms of sine squared a. And what do we know? Cos squared a is equal to 1 minus sine squared a. So I replace cos squared a with 1 minus sine squared a. But I've still got to minus that sine squared a, which gives me 1 minus 2 sine squared a. So in other words, I've shown this, cos 2a is 1 minus 2 sine squared a. So if I said to you express this in terms of 25 degrees, what's cos 50 in terms of 25 degrees, and the only trig function I want involved is sine. Okay, go give that a go. But how could I write cos 50 in terms of sine using this formula over there? Well, it'd be 1 minus 2 sine squared 25 degrees. Okay, so those are your double angle formulas. Sine 2a, there's just one formula, 2 sine a cos a. Cos 2a, there's three options. You could either turn it into cos squared a minus sine squared a, or you could turn it into 2 cos squared a minus 1, or you could turn it into 1 minus 2 sine squared a. And those are the double angle formula proofs. We don't do officially a double angle formula for tan. Sina? Right, sorry, just get that down. If you can get that down, it's got a lot on that board. Okay. Okay, so on your information sheet, you'll be pleased to know you're given these formulas. You can go check it. Sine 2a is the same thing as 2 sine a cos a. Cos of a double angle is cos squared the single angle minus sine squared of the angle, which is 2 cos squared a minus 1, which is 1 minus 2 cos squared a. And ultimately you're going to have a choice. We'll talk about what choice you're going to use, when, and try and make an educated guess as to what works best. Right. So the examples we're going to do come once again from Mind-Born Maths. Okay, this textbook over here. It's a very good textbook, by the way. Okay, Mind-Born Maths, exercise 4.4, and we're going to do A2, 5, and 8. Okay. And the first little exercise, we're going to start off with A, 2, 5, and 8, we'll do some more, is just practicing expanding using the double angle formula. So that's the instruction. Expand using the double angle formula, and you've got sine 60. So you're simply going to use this angle. Sine of 2 times an angle, so sine of 60, go try to do that. Just go use that formula. It's just one line. So it's going to be 2 sine, well, what's the relationship between 2a and a? That's half of that angle. So it's 2 sine half of that angle, which is 30 degrees, cos half of that angle, which is 30 degrees. And that's your answer. Right, for cos 20, okay, same thing, expand using the double angle formula. Okay, we don't normally ask you this, but just for practice, I want you to give 3 different versions of the same solution. Okay, now, so you're simply going to be applying those 3 formulas over there. Give that a go. Right, so if I use the first formula, okay, cos of 20 degrees is going to be equal to cos squared half of that, which is 10 degrees, minus sine squared 10 degrees, which is the same thing as 2 cos squared half of that angle minus 1. So it's the same thing as 2 cos squared 10 degrees minus 1, which is the same thing as 1 minus 2 sine squared 10 degrees. Right, so there are your 3 answers, 1, 2, and 3. Okay? Right, so 2 cos 22, if I give 3 versions of the same answer, well, again, it's going to be 2, just put that 2 outside the bracket. Okay, cos 22 degrees is going to be cos squared half of that angle, which is cos squared 11, minus sine squared half of that angle. Okay, right, and likewise, we could say that it's equal to, keep the 2 outside again. We could have said though, we also have chosen 2 times cos squared half of that angle minus 1. And running out of a bit of space, I'm going to go over here. We could also have said that's going to be equal to, using that formula, 1 minus 2 sine, sorry, I've still got the 2 outside the bracket. Okay, that 2 still, this 2 over here, still over there. So it's going to be 1 minus 2 sine squared 11. If you want to neaten them up, you can. And have to 2 cos squared 11 minus 2 sine squared 11. That one will become, this one will become 4 cos squared 11 degrees minus 2. And this one will become 2 minus 4 sine squared 11 degrees. Right, so that's A, 2, 5, and 8. Hopefully those all make sense to you. We are getting there. Alright humans, the next examples we're going to do come from my more maths 4.4b, the middle column, in other words, okay, 2, 5, 8, 11, and 13. Okay, and the question says, write as a single trig function. And first of all, we're going to do number 2, which says 2 sine 3a cos 3a. So up to in the previous exercise, we're expanding, we're working from right to left, left to right. Now we're going to be working in that direction. Okay, so apply that formula to try to get just a single trig function. Give it a go. So I've got 2 sine a cos, this formula is saying 2 sine of an angle cos of an angle is sine of double that angle. So 2 sine, my angle now is 3a. Okay, here it was just a. So the formula though is saying 2 sine of an angle, cos of an angle is sine of double whatever that angle was. So what's double 3a? Double 3a is 6a, so it's simply going to be equal to sine double 3a is, you're doing this, you don't have to show the step though, sine of double 3a is going to be sine of 6a. So I've now written that as a single trig function. Right, try number 5, 8 sine theta cos theta. Well, I've got to, it's just about manipulating the sums to get it into a formula that you recognize. So I need a 2 sine theta cos theta. So to do that, I'm going to have to take out 4 Now I've got 2 sine theta cos theta. And 2 sine of an angle, cos of an angle is sine of double that angle. So I'm still going to have that 4, and then it's going to be sine of double that angle, okay, which in other words is just 4 sine 2 theta. Right? Okay. Part number 8. It says 1 minus 2 sine squared alpha over 2. Okay? So, look for your pattern, which is the appropriate pattern. Okay, we'll hopefully see that's the pattern over there. And what this is saying to you, again, I'm working now from right to left, so give that a go. Okay, 1 minus 2 sine squared A. Sine squared of an angle is cos of double whatever that angle is. So this is going to be cos of double of 2 times this alpha over 2. Okay, so it's going to be cos of 2 times alpha over 2. Okay, and 2 times alpha over 2 is 2 over 1 times alpha over 2. The 2's cancel, and you're simply left with cos of alpha. Cos of alpha is 1 minus 2 sine squared half of that angle. Alpha over 2. Okay, try B question 11. Again, the question is write as a single trig function, and you've got cos 2 theta plus sine 2 theta times cos 2 theta minus sine 2 theta. Go for it. Okay, well, you've got this pattern A plus B, A minus B, and we know A plus B, A minus B simplifies to A squared minus B squared. Okay, so likewise, this will simplify to cos squared 2 theta minus sine squared 2 theta. Okay, and that should get you pretty excited because there that pattern is over there. Cos squared A minus sine squared A. Right, so go do that, move in that direction though, it's equal to cos of double whatever your original angle was. So in this case, what's double 2 theta? Double 2 theta is 4 theta. Okay. The formula is saying cos squared of an angle minus sine squared angle is cos of double that angle. So double 2 theta is 2 times 2 theta, you don't have to show the step, which is simply going to be cos 4 theta. Right, there's 11. Try B number 30 now. It says, okay, once again I want it as a single trig function. Okay, and now you've got 8 sine beta, cos 2 beta. Well, we're trying to compress it, so we want to work from right to left, and I've got sine and cos, so it looks like we're going to be using this formula, but we need a 2 in front. So to get a 2 in front, I take out a 4, and then I'm going to have 2 sine beta, cos beta, and that should get you all flustered, because that's nice. Okay, 2 sine beta, flustered in a good way that is. 2 sine beta cos beta, and then I've still got this cos 2 beta. Lovely stuff. Right, so now 2 sine beta cos beta, remember I'm trying to compress it, I'm trying to get it to a single trig function working from right to left. Okay, so 2 sine beta cos beta is the same thing as sine 2 beta. So I've still got that 4. This over here becomes sine double that angle, which in this case is just 2 beta, cos 2 beta. Okay, I'm trying to compress, so I want to go from right to left. So now, I've got sine 2 beta, cos 2 beta, which is that kind of pattern, but I need a 2 in front. So instead of having 4 times something, let's make it 2 times 2 sine 2 beta, cos 2 beta. And now I've got that pattern over there. 2 sine of some angle, cos of another of the same angle, is sine of double that angle. So what's double 2 beta? Double 2 beta is 4 beta. So it's going to be 2 sine of double 2 beta. So it's 2 times 2 beta. You don't have to show that step, which is simply going to be 2 sine of 4 beta. And that is question. They take a bit of getting used to, but once you get used to the patterns, you're fine. Okay, right, to return to sunny Johannesburg for our international audience. Beautiful day here, rain is cleared, birds are singing. They don't have a freaking clue about coronavirus. Right, next one is C2. And I want you to change the question slightly because I think it's a little bit unreasonable as it stands. they just said simplify that. Okay, but it's difficult to know where to stop or where you're heading. I would never ask a question like that. I would ask it as, show that that is equal to that. Okay, so I just want you to change the question a bit. Show that the original question is equal to 8 sine 2 theta. So that gives me a hint that I've got to get everything on this side to 2 theta. You could work with both sides. I'm just going to work with the left-hand side. Okay, so if you want, give that a try. Okay, the first problem we have is the negative angle. And we know that sine of negative angles behave like they're in quadrant 4, is the same thing as, where only cos is positive, is the same thing as negative sine of that angle. So 4 sine negative 4 theta will be negative 4 sine of 4 theta, just taking out that negative. With a square and a reduction formula, remember it's always better to rewrite that as 2 sine of 360 minus theta. A squared there means the whole thing squared minus 1. So squared there means the whole thing is squared, because that's going to mean that ultimately, no matter what quadrant you're in, you're going to end up with positive sine squared. So if I simplify that, okay, now we'll get back to that. I want, my answer, I've only got 2 thetas. So at the moment I'm sitting with a 4 theta. So I've got to change sine 4 theta and express it in terms of 2 theta. And to do that, I'm going to work in that direction. Sine of a double an angle is 2 sine half of whatever that angle is, cos of an angle, right? So sine 4 theta, working using the formula from left to right, is going to be negative 4. Sine 4 theta, I'm going to write as 2 sine, well, what's half of 4 theta? Because the formula is saying half that angle. So it's 2 sine half of 4 theta is 2 theta. Okay, and then cos 2 theta. I hope that makes sense. You're working from left to right there. Right, carrying at the bottom, sine 360 minus theta all squared. Well, you are in quadrant 4, so sine's going to become negative. So it'll become negative sine theta all squared. Okay, then I've got that minus 1. You can skip out steps, by the way. If you see a square, you can straight away just write that it's going to be sine squared theta. Okay, now at the top, I've got negative 8 sine 2 theta cos 2 theta. Okay, which is looking promising because there's an 8 and there's a sine 2 theta. Always keep glancing at the right where I'm trying to get to. And here, you've got 2 sine squared. If I square that, it becomes a positive. 2 sine squared theta minus 1. Which should draw your eye to this over here. But the problem is this is 1 minus 2 sine squared a. So we've got to get it in this form. 1 minus 2 sine squared a. As opposed to, I've got 2 sine squared a and theta minus 1. So what can I do to change the signs? Well, I can take out a negative. So I'll get negative 8 sine 2 theta cos 2 theta. And I'll take out a negative 1 from here, which will leave me with 1 minus 2 sine squared theta. You see how I'm constantly trying to get things into the pattern that's on the formula sheet. And 1 minus 2 sine squared of an angle is cos double that angle. So now I have negative 8 sine, well, the negatives are going to cancel. Let's get rid of the negatives. That negative and that negative cancel. So I'm going to have 8 sine 2 theta cos 2 theta. But 1 minus 2, the negatives have gone. They've cancelled. 1 minus 2 sine squared theta is cos 2 theta. Voila! And now, what happens? The cos 2 thetas cancel. And I'm left with 8 sine 2 theta, which is what I'm trying to prove. The problem is that I didn't ask the question like this, as an identity. I think it's difficult to know, a bit unfair to try to figure out where you are heading. Okay. These are tough. They take a bit of getting used to. Okay. They're just mind games. I'm not quite sure of their application, quite honestly. Okay, but they're in the curriculum, so we got to do it. And it gives your brain some stimulation. Okay, get that down. Okay, guys, right. The next example we're doing comes from the exercise, and we're doing C4, but again, I want you to change the question. I think it's a bit tough in its original form to know where you're heading. Okay, so the left, I want you to change the question. Well, this was what was, the question said, simplify sine 4 theta minus sine 2 theta over cos 4 theta plus cos 2 theta. I want you to change that to show that the same thing on the left-hand side is equal to tan theta. Okay, that's I think it's reasonable to know where you're heading if they don't ask it in that form. Right, so this is a tough sum, but you've got to just stay chilled in these ones. So the first thing I would say is, right, I've got 2 theta, okay. So the 4 theta is the first thing I would look to deal with in both cases. What you can do is straight away, with an identity, split up the right-hand side and the left-hand side. I'm going to work primarily with the left-hand side, but I can pick up some marks by saying, and it can help me later on in the sum. Okay. I can say, right, tan theta is equal to sine theta over cos theta. Right? Because I'm trying to show the whole thing was equal to tan theta. So I can at the very least pick up that mark, but it's not only that, it's going to help me in the sum. So, well, sine 4 theta, if I want to get it in terms of 2 theta, I'm going to be working from left to right in that formula. So this is going to be equal to, I'm just going to work with the left-hand side now, finish with the right-hand side. Sine 4 theta, what's that going to become? Well, it will become, the formula said it will become 2 sine half of 4 theta, which is 2 theta, half of 4 theta, cos half of 4 theta, which is 2 theta. So that's the sine 4 theta. That's that bit over there. And let's just leave the minus sine 2 theta for now. Okay. Then, now, with cos 4 theta, okay, you're going from left to right again in this scenario. The trick is now, you've got a choice of 3 things. So how the hell do you know which one to choose? And it's an educated guess. And what I would do is I'd say, well, if I look on the right-hand side, in the denominator, I've got cos theta. So, and I've got a cos already over there. And often if everything is in terms of cos, then you can factorize or something like that. So my guess is that because I've got a cos at the bottom, I'm going to use this expansion, double angle expansion over there. So go try to do that. What's cos 4 theta going to become? It's going to become 2 cos squared half of 4 theta, which is 2 theta minus 1. That is that over there. Okay? And then I've got plus cos 2 theta. Okay. Right, your next challenge, what I would look to do now, you could go try and get everything single angles, but it's going to become very ugly. Let's try and neaten it up a little bit first. And to neaten it up a little bit, I want you to go try and factorize the numerator and factorize the denominator. In order to factorize the denominator, it may make your life a bit easier just to do this. So try to factorize the numerator, but in the denominator it's going to become, just write it in a different order, it may be more familiar. 2 cos squared, sorry, that's a 2 theta. We can only start factorizing once the angles are the same. Okay? And they're all 2 theta now. 2 cos squared 2 theta plus cos 2 theta minus 1. Look for a common factor in the top. And at the bottom here, remember all the angles are 2 theta, that's why we can start to factorize. Okay? At the bottom, you've got trinomial. Okay, try to do that factorizing. So at the top, you've got 2 terms. Okay, there's a term, there's a term. Is there a common factor? Yeah, voila, there is. The common factor is sine 2 theta. So if I take out sine 2 theta, okay, I'm going to be left with, well, to get back to that term, I've got 2 cos 2 theta. That's to get back to there. That times that will give you that. And to get back to itself, there's a negative sign, it's going to be negative 1. Right. In the denominator, a lot of people struggle with that kind of factorizing. So it might help you just to go to the side of your page and say, well, if I had 2x squared plus x minus 1, there's a trinomial. Okay, I'll just replace cos with x. Okay, and it would become cos theta with x. That would factorize to 2x, x. Okay, to end up with plus 1 in the middle. This is going to have to be plus 1, that's going to have to be minus 1. 2x squared plus 2x minus x is plus x minus 1, right? So using that pattern, that would factorize to 2 cos theta. You don't have to show this, by the way. 2 cos theta minus 1 cos theta plus 1. If you times it out, you get 2 cos squared theta plus 2 cos theta minus cos theta is plus cos theta minus 1, right? And these should all be 2 thetas, apologies. Okay, so now, the angle we're working with is 2 theta. The times, because that and that, everything's times at the top and everything's times at the bottom, so we can cancel, those will cancel out. And I'm left with sine 2 theta over cos 2 theta plus 1. Okay. Right. Okay. Again, these things are going to make you feel insecure all the time. Okay. But you've got to just be patient, right? Like how it's going to work out. Okay. And it comes with a lot of practice, guys. It's not going to be something that's easy straight away, these more complicated ones. But if I look at the right-hand side, okay, I'm trying to get to sine theta over cos theta. At the moment, what's the problem? Those are single angles, and I've got theta as a double angle here. So the only thing you can really do is change it up, okay, using the double angle formulas. So sine 2 theta, there's only one choice. That's going to become 2 sine theta. I promise you, I can't look at something like this and know how I'm going to get there. It's just about trusting the process. Okay. So it's going to become 2 sine theta cos theta. That's sine 2 theta. 2 sine theta cos theta. Excuse the washing machine in the background. 2 sine theta cos theta. And cos 2 theta plus 1. Okay. Well, again, I'm going to stick with that expansion using cos because there's cos at the bottom over there. And cos 2 theta is 2 cos squared a minus 1. So this is going to become 2 cos squared theta minus 1. That's cos 2 theta. That's that over there. And I still luckily got that plus 1. Okay. Why is that lucky? Because now I end up with 2 sine theta cos theta over 2 cos squared theta. Okay, and now it's fantastic. The 2's cancel. A cos theta and a cos theta at the top cancels one of the cos thetas at the bottom. So I'm left with sine theta over cos theta, which is my right hand side. Okay, so I've got the left hand side equal to sine theta over cos theta. I've got the right hand side equal to cos theta, sine theta over cos theta. So I can conclude it by saying, therefore, left hand side is equal to right hand side. Right, that's a tough sum, guys. So please don't stress if you're struggling with this stuff. Okay, that takes quite a bit of getting used to and quite a bit of practice. Okay, just get that down. Hang in there. All right, carrying on with this exercise. For our billions of international viewers, throughout this video you'll hear some of the typical noises of Africa, in particular the washing machine, okay, which is a common call for this part of the world. So that's pretty exciting, I'm sure, for you guys. Right, 4.4D, okay, from Mindborn Maths. Okay, now the questions say, you'll be pleased to know D is a lot easier than C, that we just did. And 4.4D says simplify no calculator. And that no calculator is telling you that you're going to have to go get everything to a special angles. Okay. Right. So, again, trust the process. Look for patterns. You should be using your formula sheet over and over again. 2 sine 75 cos 75. Well, that's the pattern I'm working from right to left. Okay, so go apply that. Go from right to left. Give that a go. Then you're going to use reduction formula and then special angles. So try that one. So 2 sine 75 cos 75 is going to be equal to sine double whatever that angle is. So it's sine of 2 times your angle. And sine of 2 times 75 is sine of 150 degrees. And sine of 150 is the same thing as sine 180 minus 30 degrees. Sine 180 minus 30, which quadrant are you in? You're 180 minus, you're in quadrant 2. Okay, what happens to sine in quadrant 2? It stays positive. So it's going to be sine of 30 degrees. Shade your rear. So sine is the y-coordinate over the radius at 30 degrees. The y-coordinate is 1. The radius is 2. So sine of 30 is equal to a half. In a core maths exam, okay, at matric level, not in NBTs or at varsity, at this stage, you'd have to show getting to this point over here. You'd have to show that this reduces to sine 30. Quite honestly, at this stage, if you just use your calculator, once you get to sine 30, it's equal to half. We'd definitely say no calculator in our exams and show all working. So if you just wrote, if you enter that into your calculator, you'll see you get a half. But if you just did that, you'd get naught. Okay, if the question said no calculator, show all working. Okay, you don't have to show that diagram in your working as well. All right, try number 5. Again, evaluate no calculator. You've got sine 165 degrees, cos 165 degrees. Okay, so again, when you've got sine and cos of the same size angle right next to each other, you're looking to use that process from right to left over there. But the problem is there's no 2 in front. Well, it's pretty easy to overcome that problem. You just say, well, if I have a half times 2, then they cancel out. So it's just, you're doing nothing to it, you're just writing it in a different way. Okay? Right. And now, good times, because I've got 2 sine of an angle, cos of an angle. So I've got to apply that rule from right to left. So it's going to become, don't forget about the, still got this half here. Okay, but in brackets though, is going to become sine of 2 times 165 degrees. Okay, and that's going to be 330 degrees. So I get a half sine 330 degrees. Okay, the question said without a calculator, so you've got to go get it to a special angle. 330 is in quadrant 4, so I can write it as 360 minus something. So it's going to be a half sine 360 minus 30 gives us 330. What happens to sine in quadrant 4? Well, the only thing that's positive is cos, so it's going to become a half, negative a half. I'm going to take out the negative and put it over there. Negative a half sine 30 degrees. And what's your definition of sine? Sine is a y-coordinate over the radius at 30 degrees, which is going to be 1 over 2. Times the fractions out, you get negative a quarter as your answer. Oh, they're quite fun. Okay. Check that makes sense, please. Again, it's about getting it into a pattern, okay, so that it's recognizable on the formula sheet. Okay, question 8. Evaluate no calculator. Okay, it's 4.4D, and it says cos 15 minus sine 15 squared. Now, before you rush into that, go expand a minus b all squared. What's a minus b all squared going to be? Remind, get your brain into the right frame of mind. A minus b squared, go simplify that, and it's going to be a squared minus 2ab plus b squared. Right, so now go use that logic to expand that. Okay? Right, and that's going to become, using that same logic, it's going to be cos squared of 15 degrees times them together times by 2, so minus 2 sine 15 cos 15 plus sine squared 15 degrees. Well, this should get you pretty frisky, because cos squared 15 plus sine squared 15, cos squared of an angle plus sine squared of an angle of the same angle is equal to 1. So I'm left with 1 minus 2 sine 15 cos 15, which should lighten up your eyes, because I've got now, with this term over here, I've got that pattern, so go work, change that, work from right to left, and it's going to become 1 minus sine double 15, so 1 minus sine of 2 times 15, which is 1 minus sine 30, which is 1 minus sine of 30, the y-coordinate over the radius, would be equal to a half, and 1 minus a half is a half. Quite satisfying. That is your answer. Okay, you should be trying these all by yourself first, guys. It's a bit of a waste of time just to copy. So, again, simplify no calculator. This is D number 12. 1 minus 2 cos squared, 105 degrees. But if you've been doing your grade 11 revision, you'd know that the advisable thing to do here with a square is to write it as cos 105 degrees all squared. Okay? Clock, I hope you did that. Okay, so now I end up with 1 minus 2 cos, well, 105 degrees. Okay, feeling a bit nervous, I don't know why, but just something bothering me. Did I write the question down correctly? Yeah, I did, so it must be fine. So 1 minus 2 cos 105, I'm in quadrant 2. Okay, in quadrant 2. Sorry, I was being a bit of a dumbass. You could use reduction formula, we'd get there in the end. But I was just too busy trying to teach to an imaginary audience, remember names, etc. This, okay, 1 minus 2 cos squared 105. Okay, that should have rung an alarm bell in my head that you're looking for that pattern. 2 cos squared, okay, a minus 1. The problem is I've got to take out a negative. So it's going to become negative 2 cos squared 105 minus 1. Okay, I realized there's a problem trying to go straight to special angles because it wasn't going to give you a nice special angle. Okay, so 2 cos squared 105, I've just taken out a negative. Now I've got this pattern. 2 cos squared of an angle minus 1 is cos of double that angle. Still got that negative outside, so it's going to be cos of 2 times 105 degrees. Okay, just going from right to left, which is going to be negative cos 210 degrees, which should make you feel better. Now 210 degrees is in quadrant 3, so I can write it as 180 plus. So it'll be negative cos 180 plus 30 degrees. And what happens to cos in quadrant 3? It becomes negative. I've still got that negative outside, so it's going to be negative cos 30 degrees, which is cos 30 degrees, which is going to be equal to root 3 over 2. Right, we have one more sum to do for the term. Okay, your last sum for the term. So show that it's question E. Okay. Show that sine 8 theta is 8 sine theta cos 2 theta cos 4 theta. Now normally, I suppose you want to work with right to left, but actually in the double angle formulas it's probably going to be easier to work from left to right. You could probably work from right to left and it would work out quite nicely. Okay, but I'm going to work with the left hand side, which is sine 8 theta. Okay, and again, you're not going to see the answer, you've got to trust the process. So I've got an angle with 4 theta. Okay, there's no 8 theta on this side. I've got to keep looking at the right hand side. So sine 8 theta, I'm going to go in from left to right. I'm expanding in this sum. So I'm always going to be going from left to right. Okay, you could reduce by going from right to left. So sine 8 theta, or sine of 2 times an angle, is 2 sine half the angle. Half of 8 theta is 4 theta, cos of 4 theta. Now, if you look here, well, I've got a 4 theta there, so I'm not going to touch this. Okay, that I want in the answer. However, there's no sine 4 theta over here, so I've got to change that sine 4 theta. And again, I'm going to use my double angle formula, going from left to right. So it's going to be 2. Well, what's sine 4 theta going to become? 2 sine half of 4 theta is 2 theta, cos of 2 theta. So that's that over there. I've still got this cos 4 theta, doesn't need a bracket, over here. Right? So now, if you want to make it prettier, I've got 4 sine 2 theta cos 2 theta cos 4 theta. Keep looking at the other side. So I've got the cos 4 theta, I want that to stay there. I've got the cos 2 theta, I want that to stay there. But there's no sine 2 theta over here. So I've simply got to change that sine 2 theta. Still got the 4, so it's going to be 4. And sine 2 theta is going to become 2 sine theta cos theta. Okay, and then I've still got that cos 2 theta and that cos 4 theta, which will give you 8 sine theta cos theta cos 2 theta cos 4 theta. Okay, which voila is that side over there. Okay, very nice. And you've just done your last sum, new sum for the term on the video. Okay, Matrix, all that's left to do for the term, please, is in your mind, well, maths, see the examples, page 136 to 139, if you want to read through some extra ones. Okay, they're optional. And then exercise 4.4, do the sums that we didn't do as examples. And if you look in your WhatsApp group, I've made it explicit what questions you have to do. Then just a change in the exercise 4.4. In the question they just said simplify cos 180 minus 4x plus cos squared 2x, just to make it a little bit more manageable. I want you to write it as show that what was there is equal to sine squared 2x. So just show that it's equal to sine squared 2x, and likewise number 3, it said simplify that. Okay, that stays the same. Okay, and I want you to instead make it show that that is equal to negative 1 over 8 tan 4 theta. Right, well done guys, congratulations. You made it to the end of the term. It's been challenging, I'm sure, okay, but you are brave warriors. Right, so just make sure you get that down. On my side, farewell, thank you, goodbye.